So, hello everyone, welcome to another of our tech talks. I'm Kevin, and today I've got Dave with me. Dave, do you want to introduce yourself?
Hi, I'm Dave Sanderson. I'm tech director at Kitronik, so I run the team that gets to invent all the lovely toys that we sell.
Yeah, sounds like a good job to have.
Sometimes.
Yeah, so today we're going to show the Python Inventors Kit, which is a new version of a kit that we've had for a long time now. It's one of our most popular kits. We've made a few alterations to it, haven't we, so that it's used with the Python coding language. Should we
probably say it's for the microbit?
Yeah. So it's Microbit Inventors Kit, and you can code in Python and also in blocks. So we can show you that now on the website.
Yeah, I'm just trying to, there we go. Just getting used to technology. Technology is not my strong point. There we go. So this is the web page on our website for the Python Inventors Kit. It's stock code 5669 there.
Yeah.
And so this is the what you get in the kit, and we've got one here which we'll unbox in a second. It's £20, give or take, plus VAT, and it's in stock. So buy them now. Yeah,
we do also do this in a box of 20, don't we? Which we won't show you now, but for people buying in larger quantities, it's a slightly more economic way of buying the products. So yeah, I mean, so you can see the little symbol there, can't you, on the website? We've just sort of gone past, but it does show you that it works with both the original version of the microbit and also the version 2, which has just been released. So whichever version of the microbit you've got, you'll be okay, won't you, with this product?
Yes, we've tested it with both of them. We did a lot of testing when V2 came out with all of our products so that we could make sure which ones did or didn't work with V1 and V2. Everything, of course, worked with V1 because that was the original thing.
Yeah.
So shall we go to a real box and have a look at that?
We can do, yeah. Sounds good.
Okay.
So the kit itself, Dave, would you say it's designed for classroom use or for home use?
It pretty much fits both because it includes a comprehensive instruction book, which allows the teacher, which in this case could also be a parent, to be just a little bit ahead of the pupil, or the pupil to self-study. It fits into education quite nicely because there's not a great need for really close supervision, but it fits well in the home learning environment as well. At home, I'd say probably if you were age 10 or up, that's a good starting point. And it introduces electronics and coding, which are two fundamental building blocks of the modern world. In schools, I think probably secondary school upwards, I think it probably isn't a primary school product, even high primary school, although no doubt we'll get some primary school teachers on saying, we use it with great success. So this box here is how it comes. It's just turn it over, and on the back is a list of contents and a little bit about the box. And then inside we have this booklet that I mentioned earlier, and then a whole load of stuff. I'll just move this out of the way and then bring the pieces back in, so to speak.
So all the learning materials within that booklet you would see there then?
Yes.
Yeah.
There's also some additional learning material on our website for things that aren't in the booklet. And a bit later, we might talk about how you can expand this later with some add-on packs that increase the things you can teach. So in the box, there's a lovely little plate with, get it right around, with a nice Kitronik logo on it. We use that to mount so many bags. Okay, there's a screw down on the floor somewhere now. This is the edge connector board for a microbit. I've got a microbit here somewhere. Here we go. Just grab this microbit out of here. So this lets you connect the microbit, and then it breaks out the pins on the microbit to pin header, and then you can use jumper wires. And that screws onto the board about there somewhere. And then those jumper wires you use to build circuits on a breadboard using these jumper wires. So I was going to lay all this out really neatly, but it's not really. And then to build the circuits, there's a whole raft of components, as you'd expect, to do electronics with. So, try not to throw them on the floor. What you can't see from that camera is me juggling tiny things. So there's some switches. There's a variable resistor with a little control handle. These switches are very, very fiddly when I'm trying to reach across a desk sideways. There's a motor, and so you can see the motor is spinning. There's a little fan. One of the experiments uses that fan to spin the motor the other way and generate some electricity, like a wind turbine. There are some different values of resistors. I'm just going to move the book out of the way slightly. And then there are also the lovely colourful sweetie bits. So there's some red LEDs, some orange, and yellow, and green. There's a thing that looks a bit like an LED, but is actually a light sensor. There's an LED which has many, many legs. If I hold that over the black plate, you probably see that clearer. And that's actually several LEDs all inside one package, so you can control the colors of them. That's one of the experiments. There's an electrolytic capacitor for understanding about charge and capacitance. There's a little transistor for learning about how transistors can be used to drive things. There's a little speaker buzzer for making a noise, because people love making a noise. The original V1 microbit, of course, didn't have a sound output on it. The newer V2 does, but we can cover that in a minute when we look through the blocks. And there's a little terminal block. And it all comes in this box.
So these are kind of I guess the most sort of common components that you would sort of learn about in electronics.
Yeah, they're the fundamental building blocks of most electronics. Almost every circuit has some resistors in it. If you want to indicate something to a user, you'll use some form of light, like an LED, quite often, or a buzzer to make a noise, to like beep, 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 or your phone ringing, that kind of stuff. Motors and generators, they're quite a normal part of the world now, aren't they? You look at it when they see some wind turbines. So yes, we cover the basic elements of electronics and the basics building blocks for a lot of circuits.
Yeah, I think it's been a popular kit for us, because you're not just learning coding, are you? You're learning coding, but you're also learning electronics at the same time.
Yes, and the two go hand in hand quite well. To control electronics, quite often nowadays, there's a microprocessor. There's microprocessors in your washing machine and in your telly and in your phone and all over the place. And one thing the microbit does really well is make that physical computing accessible for learning. And speaking of learning, we have, of course, the course materials. So I'm just going to move these components back out so I don't knock them all over onto the floor.
Yeah. And
then we'll have a quick look through the book.
And is there extra parts the user would need to use in the kit? I mean, obviously you've shown the microbit already, but is that what they need, or do they need anything to go on?
A screwdriver.
Yeah.
To assemble it. So the board, as I mentioned, you screw it onto these pillars on the plate so that it holds it. I'll show you an assembled one in a second.
Okay.
And you need a microbit to drive the circuitry. And of course, to program that microbit, you need a USB lead to connect it to your computer. All of the things that you'd find in we do a microbit starter pack. So here, there's a USB lead and a microbit and a battery cage and such in here. And you can use the battery cage. Here's one I pre-built earlier. There's a little place on the plate for the battery cage to sit nice and neatly and power the microbit.
Okay.
So you can power it either from the USB lead or from the batteries that came in your starter kit.
So you wouldn't need to put, so the USB would power it anyway, but if you wanted to move it around and make it portable, you could then use the batteries.
Yes, yes. So
yeah.
if you want to take it away from where a computer is, you need some way of powering it, and the microbit battery, 2AA battery cage, 2 AAA battery cage powers it fine, powers all the experiments.
Super.
So the book, as I mentioned, it introduces this from a position of you have no knowledge, we'll work through it all completely from the ground upwards. So there's a little bit about how you put it together. There's a very nice couple of pages with pictures of what all the components are. So these push switches, for instance, which are it's going to be really, if you can see that push switch. Yeah. So there's a nice illustration to help you identify what the components are, which helps later on when you actually build the circuits. And then there's LEDs in colors and the resistors. Their values are denoted by a little code, which is colored stripes. So we put the colored stripes on them, but we also tell you what the number is. So you can learn a bit more about how electronics is designed in that sense. Then there's a little bit about how a breadboard works. So as I mentioned, you build the circuits onto this breadboard, just plug components in, and people may never have seen a breadboard before when they're picking this kit up. So we felt it was important to show people how these things work. And then of course, there's a little bit about a microbit. Because this is a beginner product for microbit, we thought we'd best show people a little bit about microbit and how to use it. So if I just share this, where's it gone? That one.
So yeah, I mean, they're all based around MakeCode, aren't they?
Yes.
Yeah. And
so all the projects in this book are MakeCode based.
And it's a free product, isn't it, MakeCode? It's
yes, it's web based. So if you go to makecode.microbit.org, you'll get a page looking a bit like the screen I'm sharing now. And to create projects, you press the new project button, and we're going to live code the first experiment because why not, to live dangerously. So I shall give it a name, experiment 1. As simple as that, we're creating a project now to code the microbit to do something. So back in the book, we run through the basic blocks. So this is block coding. It's a bit like Scratch or Blockly or those kind of beginner coding languages. And it's a great introduction to how to code. It's a bit like picture books when you're learning to read. It's very simple and straightforward. And you do it by snapping things together. So shall we move on to?
So you're going to create that. I think one thing that might be useful for anybody is obviously being live. If anyone's got any questions, they can leave those in the YouTube live feed. We've got more there checking those questions for us, and we'll endeavour to answer them while we're on today. So if anything's confusing or you want any more information or any questions, please let us know.
Yeah. So the first experiment, it gets a couple of button inputs on the microbit. On the microbit, there are a couple of buttons. Over here in MakeCode, there's a simulator for button A and button B. So when button A pressed and when button B pressed, we do something. I'm just going to put these other blocks that we don't need in the bin. And then on button A pressed, let's have a smiley face. And on button B pressed, let's say the traditional greeting from any computer program ever, which is hello world, which is like the beginning of the world. So the nice thing about the MakeCode environment is there's also a simulator of the microbit. So you can test your code before you download it. So I can press this button A and I get a simulated smiley face. So over here, here's one I prepared earlier in true Blue Peter style. I just plug the batteries in. So this is we're not on the screen. This is the experiment 1 circuit, and move that way. The build of the circuit is detailed in a nice, easy to follow picture way. So these 2 buttons here are these 2 buttons here, for instance. But also we give you the actual electronic schematic. So you're learning physical components and how you would draw them if you were doing design work. And then you're also learning how to code to make them do stuff. So this button here should produce a smiley face, just like this one did. It's quite interesting that you can see the way the screen is flickering. My eyes looking at that screen, they're on, but the camera is picking up how fast the processor is turning on and off all those LEDs to make a picture. And if I press the other button, it should say, "Hello world," which is the traditional greeting from any computer program.
I think you can just about see that, Dave.
You can just about see that. I wonder if stopping the share might help, because it'll make us a bit bigger, maybe.
There we go, yeah. So each experiment in the booklet is quite simple, as it tells you which blocks you specifically need, which components you need,
yeah,
what to build.
Yeah, so here's the little block for the button A press, and here's a little block for button B press, and here are the things, and it explains how to do the block coding. And then the block coding experiments, they get a bit more complicated. Let's move that out of the way again. And you get slightly more complicated circuits. And as you go through, it builds up the your knowledge and your confidence, hopefully. And then
I was going to say, Dave, I think like the fact that it uses them sort of core components you would use in electronic circuits, we've also tried to make sure the experiments cover the core blocks only within the make code itself.
Yes. So this initial guide at the very beginning covers most of the blocks in I'd say that the important blocks for a program. So you've got things like button inputs, and you've got if statements. So if something happens, do this, else do that. So you can make choices within your program about how things occur. Covers about variables. So variables are like a little place to store something and remember it. So at the beginning of the world, you might press the button 3 times, and you might want to say, "Oh, I've pressed it 3 times." You'd store the number of presses into a variable. Yeah.
So I've got a question, Dave.
Uh-huh.
So we've got Tony is asking, why don't we use the Mu editor, which has an excellent microbit mode?
Aha. Right. Well, we're about to come to that, because the book here is designed to be used with just make code, so you don't need to install anything, and you can just go to a web page and use it. Make code now has Python as part of it. It's not the same Python as you get with Mu. Mu is proper MicroPython. It's not the same back end as the make code is. So we chose to use the make code Python in this experiments book because it makes it very easy for an end user who has little experience to step from not knowing anything to knowing a little bit about how to put stuff together in blocks to then progressing onto a text-based editor. From there, you can then take the next step into full-blown MicroPython on a microbit, or indeed Python on a Raspberry Pi or any other processor.
So you see this more as an introduction to Python in its simplest form?
Yes, yes. And the way the make code environment integrates, it's very nice for that, because there's always that little fallback. Maybe I should just...
Should we show people how you switch between them?
Yes, that's what I was just thinking.
I think it'll be interesting for people to see as well that obviously the original version of the Inventors Kit, which we still sell, still very popular, uses JavaScript, doesn't it?
Yes. So handily, I have here a JavaScript booklet and a Python booklet. They look fairly similar.
Yeah.
So hopefully you can see on the screen there some Python code. So
Yeah.
this is the one of the experiments from the Python section of, I'm on the wrong camera. Let me just change camera to the booklet again. Right, so this is the Python code that's associated with experiment 8. So here we are, here's the Python code. So we have an experiment here that uses the inbuilt compass and then plays a game with that based on trying to guess where you are based on how flashy a light is. I should probably say before we get there that we introduce Python a little over 2/3 of the way through, and we introduce it by relating it back to how the block codes work. And so in blocks, in the MakeCode editor, you can see things in, oh, it's all got itself in a piled on top of each other way. Here we go. So these are all block codes, and I can flick between the blocks and the Python representation quite quickly. And I can also actually flip to a JavaScript representation as well. So we felt that the integration within the MakeCode environment made this more suitable for beginners, really, than new. So back here in the experiment 8, we've got some Python code, which we can see here on the screen. And again, I can simulate it in the simulator because we're using the compass, which is on the microbit, and I can just flip this bit around to change where the compass is. That's a bit like me rotating the microbit, but virtually. And the output here is toggling based on the difference. So in the code down here, we get the compass heading, and we've got a goal, which is our guess the number. And then we toggle the pin based on how far away we are from our goal. So as I move around here, it speeds up a bit, and then it speeds up some more, and about there, it's speed up really fast. You can see that flickering. So I have that programmed in this one. This one's being powered from the USB lead, just from the computer that I'm running Zoom on. And you can see here, I've got to calibrate the compass. So the microbit has a magnetometer on it, which it can use as a compass. And to calibrate it, when it finishes scrolling the message telling me to calibrate it, you just have to tip the little red dot, if you can see the red dots, but you tip them all over the screen, a bit like running a ball bearing around in a maze game until the screen gets full up of red.
So this is the same effect you see with mobile phones, isn't it, when they ask you to do that sort of figure of 8?
Yes, yeah. And so now you can see the LED down here is flashing away. And as I turn this, the rate of flashing will change. I'll turn it. There we go. This way you can see it's flashing much faster. And somewhere around here, there we go. So that's flashing really fast. So I think I'm at the right point now. So I'm going to press the button A. Hopefully it'll give me a nice message saying winner. Hey, it does. And so this little game, for want of a better description of it, is using some inputs from the real world, using some user interaction to twist around and pressing buttons, and you've built a circuit and you've coded it. And hopefully the way we explain how to do all that means that you actually understand what you're doing. Yeah.
So that's quite a simple circuit there, isn't it? But generally through the booklet, they get progressively more complicated, don't they? And so does the coding.
So the circuit, the circuit is literally a couple of wires, LED, and a resistor, which to somebody who's experienced in electronics is like, oh, that's dead easy. Somebody who's never done it before, that might as well be a spaceship. But yes, we do. we get more complicated as we go through. And so this circuit, for instance, has got quite a lot of components on it, quite a lot of wires. And when it's drawn out in the schematic, you can follow how the schematic relates to how the stuff is connected in the real world. And that's a useful tool for designing circuits.
So how many in total are there within that booklet, Dave?
So there are 10 experiments in this booklet. And they go through things like, is there a contents of them? Yes. So they go through things like saying hello, which is just, you know, a very quick introduction here. Don't be scared of the mic a bit. All the way through things like how a capacitor charges and introducing the rules for capacitor charging in terms of how fast a capacitor charges, using wind power, like I said earlier, and then also reading multiple inputs to control the hue of a red, green, blue LED, which is a sort of thing you get in your smart lighting in your house.
So you could build a sort of an Alexa controlled light almost.
Yeah, something like that.
Yeah, that sounds great. So that covers sort of the basics of what's included in that kit. Earlier you talked about the fact that you could also add some expansion packs onto this if you wanted to. These are separate products that we sell on this, so these are.
Yes, yeah. So those first 10 experiments give you a nice introduction into general electronic coding stuff. And then we did some thinking about it and we decided, oh, maybe there's a market for people to expand what they've done when they've used the Inventors Kit and they're quite happy. Maybe they might want to do something with, let me just switch to the other camera. Something with some more controllable LEDs. So these are zip LEDs. They're programmable LEDs, so you can tell them to be a different color and you can display rainbows and all sorts. They're really pretty. People just love to make pretty pictures with them. And in there you get, again, another one of our lovely, as well as the actual kit you need, there's another booklet, which again is done in the same sort of style of, here's how to put the circuit together and how to code it and what's going to happen.
I suppose just sort of looking at those kind of, that's there in blocks, aren't they?
Yes, the extension packs are all in blocks, partially because it's easier for us to write a compact instruction book for people, and also because they're designed to give you the building blocks of away you go and do your own things now.
Yeah.
So another one we do is the noise pack, and this covers making tones and noises, and again there's an amplifier and there's a speaker and there's this little touch board, so you can make a little musical instrument with a 3-key keyboard. And
do these components plug into the breadboard like you would normally, or they connect through onto the?
Yeah, here's, I don't know, what's this? This is building a filter. And the circuit is built on the breadboard, and it's the same breadboard, and if you need additional wires, we supply additional wires, of course, but it's the same components, and some of the components used in here are already part of the Inventors Kit back. So that helps us to only give you the extra bits you need, which keeps the price down, which is better for everybody. And then there's also, we looked at the curriculum, and there wasn't really a good way of teaching digital logic, we thought. That was hands-on and like physical. So we put together a curriculum-friendly pack of little logic chips. And again, this also builds into the, I can't get left and right and up and down properly yet. My head's not got it. This again builds onto the breadboard, just like the Inventors Kit ones. And it builds up to some pretty complicated digital adding circuitry.
Wow. Yeah.
And that's an adder, which is one of the fundamental building blocks of the inside of a computer. Because although computers look really clever, all they're actually doing is very fast maths.
That sounds very much like the kind of thing I was learning way back when I did sort of GCSE electronics. even in
Yes. Yeah.
physics.
Yeah. We examined the curriculum and wrote the experiments to cover a big chunk of the curriculum in a very nice way. And also it keeps kids engaged because they are doing something physical. They're not just sat there learning from a PowerPoint or from a textbook.
Right. Yeah. So one of the things I was thinking then is, so obviously the earlier experiments in the booklet are in blocks and the latter ones are in Python.
Mm-hmm.
But once you've learned that Python, I guess you could go back then and then redo the earlier experiments in Python.
From blocks to Python. Yes, certainly. And also, if you were interested and you wanted to experiment earlier, you could draw the blocks and flick it to Python and have a look.
Yeah.
And that's what's really great about the way the MakeCode environment has the blocks and the Python. They coexist. They're actually the same program. They're just rendered onto the screen either as blocks or as Python, depending on which one you've picked.
So you'd end up with the same hex file or program that you put onto the microbit, irrespective of the version you choose to code in.
Yes, yes.
Okay. So, what kind of thing could you do with the kit afterwards? I guess, you're not stopped there, are you? You've got all the components that you've got in the kit. You could go away and make your own circuits probably, or?
Yes, yeah. So you've got switches and LEDs and buzzer and a spinny wind thing. So maybe you could make a device that monitored the wind speed outside and drew a little bar graph on colored LEDs depending on how windy it was, and then sounded a horn if it got really bad.
Yeah. So the world's your oyster really then with regards to what you do afterwards, but you sort of learned the fundamentals of what do the components do and how would I interact with them using the software editor.
Exactly, yes.
Yeah. And you can add your own parts, I guess, to the kit, provided they go into the breadboard.
Yes, yeah. So any leaded parts, as long as the legs on them are the pretty standard lead size, they'll plug in. And that's the beauty of a breadboard, is it's designed for one-offs and prototyping and fiddling about with electronics. That's its whole reason for being. In the real world, once you've done your breadboarding, you then take your breadboard circuit and you make a printed circuit board from it, like a microbit, and put components down and make hundreds of them. Breadboards aren't very good for hundreds, but they're brilliant for ones.
So it's good for trying things out, but before you move to a permanent solution.
Yes, yes, and for experimenting and, I wonder if that will work, that kind of thing.
During
lockdown, I experimented with making a theremin type device. So it used the microbit to read the distance from a distance sensor and make a squeaky noise based on how far or near the thing was. It really annoyed the kids.
Kept you busy.
Yes.
I guess we also do a simpler version, don't we, for people that maybe don't want to dive straight into the sort of full-blown Inventors Kit.
Yes, we do. I happen to handily have one here in a Blue Petery style. So I'll switch to that camera. There we go. Oh, I nearly got it in the right place. So we also do a thing we call the Discovery Kit, which is a bit like an Inventors Kit Lite. It's a little bit simpler. It's got less stuff in it, and all the experiments in it are blocks. Again, it comes with a booklet, which again explains. Find the beginning.
Same concept, isn't it?
Same concept. It explains how to hook the thing up, what the code is, what the actual circuit is, and then actually how it's working and what it's doing.
Yeah.
And this has 5 experiments in it. So half the number of the Inventors Kit, but it's about half the price. And it builds from simple sort of turn on an LED circuits to a traffic light type sequence for like crossing the road with a buzzer sounding and everything.
Yeah. So that's a lower cost entry. I think they're about £10, aren't they, those kits?
Yeah,
so,
something like that.
Depending on how many you buy. So yeah, if people maybe look at the Inventors Kit and it's maybe a little bit scary for them, I wouldn't say it was a scary kit, but if you're looking for something even simpler, then that could be a good option.
Yeah, yeah, and it comes with the really nice. Just get it out here, as well as it coming with the really big chunky LEDs, which people love because they're just like. I look at them and think, oh, comedy LEDs, because they're really big, and you see the size of them compared to my thumb there. But it also comes with this really nice little connector for plugging microbits into breadboards. And it makes the microbit appear on the breadboard as though it was like a normal integrated circuit.
Yeah.
Which is what breadboards were originally designed for. So you could plug integrated circuits in and wire them up to do your prototyping.
Yeah, people might not know that, but sort of there's that break, isn't there, down the center of a breadboard where the connections don't run through, so you can.
Yeah. So here, there's a set of so that let's explain a breadboard briefly. There's a set of strips that run front to back here, top to bottom on your screen, which are used for power, plus and minus. Then there's a set of strips that run acrosswise, but they only run from the power to this little break here. And then there's another set of strips on this side that run acrosswise, and then there's another set of powers. So these switches are bridging that middle bit because of where I've placed them in the breadboard. But also you can put like ICs. So in the digital logic pack, that's where the logic chips get placed on the breadboard.
Yeah. If you didn't have that break, the two legs opposite each other would be short enough.
Be connected together.
Yeah. So people will learn about all this kind of thing when they use the kit, won't they? So,
yes. Yeah. And this is the sort of stuff that you'd learn. Well, I learned quite a long time ago.
Yeah, we won't say that.
Just when we were starting out in our electronics learning journey, Kev.
Yeah. You didn't really have microcontrollers that you could use. Well, I don't know about you, but the ones I used to have to erase them, you put them in the UV box things for half an hour.
Yes, the microchip tanning salon.
Yeah, just to find out your new program didn't work again, and you're back in a half an hour cycle.
Yeah, well, you see, I always used to erase too.
Oh, great. Let's just see if there's any more questions. So someone's asking us maybe we should make a lot of the Adafruit industry style products because of Brexit, it might be easy to get in the UK. Well,
yeah.
There's a few things to tackle. I'm sure they've got a few thousand products to look at. Yeah,
indeed. Although on that note, the Clue which Adafruit build is a microbit sized and microbit. It's got the same edge connector shape on it, and the Clue does work with quite a lot of our microbit accessories. Maybe we'll do a tech talk on those at some point in the future. But yes, Adafruit do a lot of really good stuff.
They do, yeah. And the other comment I've seen there is that obviously with the new microbit version 2, if people do want to move on to things like the new editor, there's more capacity, isn't there? Chip space memory space on that.
Yes, yeah. One of the big I don't know, limitations, that's probably the right way of putting it, with the V1 was when you loaded MicroPython on it, you're quite limited with how complex your code could get. And one of the things about using Python is that a lot of people, when they go into Python, start doing complicated things. So there was a bit of a tension there. But yes, the V2 microbit is much, much better for that because it's got, I think it's twice as much memory, something like that anyway. And because Python is, of course, a curriculum language now, in a lot of the world for teaching computing, it's a nice way to expand your desktop teaching into making things really actually move around the world. And that's kind of what engineering's about, isn't it?
Yeah, I mean, you're right there. It's one of the things we do get a lot of requests for now, particularly like in other countries like France and Germany and places there, extremely heavily focused on Python. So that's obviously one of the reasons why we've looked to produce this kit, so that it's more closely aligned with people teaching Python as part of their computing curriculum.
Yes.
But we still sell the JavaScript one as well, don't we? Because that's also very popular.
Yeah.
I think what's good for anyone, if you bought either version of the kit, because MakeCode can flip between the languages, you could move over and learn the opposite one, couldn't you, quite easily, I think.
Yes, yeah, and once you can, the main thing is the stepping stone from what I'm going to call picture book coding with the blocks to reading a real book coding with typing the words. And once you've made the step from blocks to words, what language the words are in it's less hard to learn than that initial step from blocks to words. So although the syntax, how you type the words and what they really mean in JavaScript and Python is different, there are words that are sufficiently similar, like if, for instance, that they mean the same thing. So you can read one code from the other code. And that, of course, is just part of the learning journey. I can write in several different languages. And I know Jeff, the other Kitronik guy, he used to write in several languages at once, which was quite funny because the compiler used to throw it away and say, no, can't do that.
Yeah, it can be fun switching from one to another. I mean, I see all some of the comments on here, Dave, that, you know, if you are using something like the clue, obviously that's also, you can code that with the Arduino IDE, so you can code in C.
Yes, or CircuitPython is very popular on the clue, and there's a lot of supported libraries for doing all sorts of things with the clue. So that's a Python that Adafruit and others are actively developing extra stuff with. That's also based on the MicroPython port, which is like the MicroPython that you get with the Mu editor for the microbit, for instance.
But all of these could be used with our kit, can't they? I know Adafruit do stock our Inventors Kit, you know, because you can plug their board into it as well.
Yes.
You know,
I started writing a game for the clue using our game controller, for instance.
Yeah. So I think all in all, really, what we're saying, it's a great kit. You can use it with no experience whatsoever. You know, it's your first experience of coding, maybe building some electronics, and it will take you from that no knowledge level up to understanding what you're doing. But if you're a more advanced user, you could still use it with these additional coding platforms and things, and move on to, you know, a much higher level, really.
Yes, yeah, you can. It's expandable all the way.
Yeah. I suppose that's the whole point behind like Inventors Kits and prototyping systems, isn't it? You know, sometimes it's a simple system, but other times it could be quite a complicated thing.
The reason I have several of these kicking around here is because we use them actively in the development of products. So yes, you can use them in industry.
Fantastic. So I don't think there's any more questions, Dave.
Okay.
Is there anything that you think we've missed out here or want to cover?
No, I think we've been through the Inventors Kit. I mean, it was a pretty whistle-stop tour. There's a lot more information about it on our website. And also, of course, there are additional help pages and tutorials and stuff too. So if the book doesn't quite cover it, there's probably some more information on our website. And if not, there's always our fantastic customer service team who will find the answer for you, even if it means they come and bother me.
Yeah. Yeah. I mean, for each experiment, we do have like a sort of a help section, don't we? Whereby, you know, if you think you've built it correctly, or maybe you're unsure if you've done the software correctly, you can actually download an example program. So, you know, sometimes it's hard, isn't it, when you think, well, have I built the circuit right? Have I got the code right? I'm not sure where the fault might lie. Sometimes, you know, if you take the code you know is perfect, then at least that will eliminate one of those things.
Mm-hmm. Yeah. And they're available in foreign languages, of course, as well.
Yes, we're working on that, aren't we, for some of these Python versions.
So the JavaScript version is available in, I think, French, Swedish, Dutch, Spanish, many languages. Some on our website. I can't remember.
There's quite a few.
But we're looking to do the same for the Python 1 across many languages, so people can code and learn in their native language, which I think is an important thing because not everybody speaks English.
No. And you can flip the blocks, can't you, as well, in the block things to different languages should you want to use them in a different language.
Yes. One of them, the really good things about the make code is it is international and it's internationalized in the blocks.
Yeah. Well, great. Well, I hope that covers off for everyone. If people do have questions, you know, you can continue to leave comments on the YouTube. We'll put this video live afterwards, so you can comment below, and then we'll get some of the guys here to answer your questions if you do have any. So. Okay, Dave, well, thanks for your time. I think we're doing some more talks later in the week, aren't we? So
yes, there's one tomorrow for buggies, and Thursday is arcade games.
Yeah. So tomorrow's our last sort of microbit focused one. Then we're doing one that uses the make code bit for the arcade product, which is slightly different. And then we're doing one that's more focused on electronic kits on Friday. So yeah, they'll all be available as well on catch up if people want to get them later on.
Yep, and if people like this format, maybe we'll do some more on other things.
Yeah, well, it's a good thing if people want information on certain products and they're looking for a video, maybe comment on that, and it's something we can look to produce for people.
Yeah.
Okay.
Ask the audience.
Fantastic, Dave.
All right.
Well, thanks for your time today.
No problem.
Okay, cheers.
Bye.
Bye, everyone.